So we have the positive rotational angle. A positive rotational angle is actually counterclockwise. So the first thing you should do is label your axes. And we're going to learn this stuff really well for the first little bit here in degrees, and then you're going to go into radian measure as well. Okay? So that means I shouldn't see a phone out. No phones. If they're out, please put it somewhere where you're not going to want to touch it. So that means away off your desk, not in a pocket, not anywhere. Okay, so we have 0 degrees starting at the far right. It always happens that way. Then we are going to go counterclockwise. So then this is going to be in 90 degrees later, right? It makes that little 90 degree symbol. Yeah? Then another 90 would be 180. And then another 90 is 270. And then another 90 is 360. And could we keep going on for life? Yeah, we could just keep going. What would end up happening is we get coterminal angles. They're angles that end up on the same spot. So for example, 0 and 360 are coterminal because they would actually end on the same terminal spot, would they not? So they'd be coterminal with each other, which we're going to talk about. So a positive rotational angle goes counterclockwise. So let's do, for example, 210. Remember your quadrants go 1, 2, 3, 4, and that's the reason why your quadrants are wonky and start in the top right and go around, because they actually follow rotational angles, positive rotational angles. That's why they start in the top right and go backwards. It's been super frustrating for you for life. But this is why. Okay? It all comes full circle. Now you know. So where would 210 fall? Into what quadrant? 3. And how much more is it than 180? 30. Remember, each of those little quadrants are actually 90 degrees total, correct? So it's a third further than 180. So if I broke this into thirds, good English, into thirds, this would be 1, 2, 3. I could cut it into 3 pieces, correct? That would be 30 degrees, 60 degrees, 90 degrees. We agree? Okay. So when we want to draw our rotational angles, we need to have an initial arm first. Our initial arm is on the 0. We always rotate about 0, 0, the origin. So here's our initial arm. You have to draw your initial arm so you know where you start. You can't just assume someone knows you start at 0. Okay? And then we draw our terminal arm, which is about a third past 180, because it's 30 more. We agree? This is our terminal arm. This is where we start. Initial, this is our terminal. And then you actually have to draw where the heck the angle is, because I could have an angle actually going clockwise. You don't know that yet, but in about 43 seconds, you'll realize that that's a negative angle. So we could actually have a negative angle that terminates on the same arm. So we have to actually draw it from my initial to my terminal with an arrow. That's why these arrows are so important. If you don't draw the arrow, the angle could be on the other way, right? Could be on the other side, which is a totally different angle. And then we label it 210 degrees. All right? So you need an initial arm, you need a terminal arm, you need to rotate about 0, 0, and then you need to write it out. Then we have negative rotational angles. Lesson. These go clockwise. So we label our arms differently. We still start at 0, but now we're going clockwise, and instead of it being positive 90, it's actually going to be negative 90. So we start here and we work to this arm here. So this is negative 90. And then we go another 90, so we get negative 180. And you need the degree symbol. If you don't have the degree symbol, it's a radian measure. You don't even know what that is, so you really don't want it to be that right now, because you don't even know what a radian measure is. So if you forget the degree symbol, it's actually radian, which you don't know what that is. So bad for now. Okay? So you have to remember your degree symbols. Go another 90, we get negative 270, and then we'd have negative 360. So we said back here 0 and 360 are coterminal. What else is coterminal with 360? Negative 360. It would end on the same arm, wouldn't it? Okay, I'm now going to do negative 150. What quadrant would it land in? It would still land in 3 this time, right? Because it's between negative 90 and negative 180. So it's in 3. How much less is it than 180? Huh. Did you look at that? They land on the same spot. It's as if I planned this. Craziness. Yep, absolutely. So I arrow this way and say it's negative 150. So if I didn't put the arrows to tell you which way you're going, it could be so many answers, couldn't it? Now we know that 0, 360, and negative 360 are coterminal angles because they end on the same arm. We agree? What else is coterminal here? Negative 150 and 210. So coterminal angles will be your best friends because first off, they'll ask you what a coterminal angle is, but not only that, coterminal angles will be your best friends because when I give you an angle that's not from 0 to 360, you can make it be from 0 to 360 by finding its coterminal angle, and then it's easier to pull answers off your unit circle. So coterminal angles are angles that terminate on the same arm. Just leave it there for a second. Could you think of an easy way that we could possibly figure out coterminal angles from giving you an angle? How far apart are 210 and negative 150? Yeah. Exactly. So to end on that terminal arm, it's as if I taught him this last year. It's to end on, you don't remember it though, probably. No, he was really good. To end on the terminal arm, you would have to rotate 360. 360 is a full circle, is it not? If I rotated a full circle, would I not just end up on the same arm? Yes. So a quick way to find coterminal angles is to either add 360, which is what you said, or subtract 360, which is also what you said. Because if you went from the negative, you could add it. But if we went from the positive, we could subtract it, and we'd end up on the same arm. So an example would be, if I gave you negative 150, how could you get to 210? Add 360. And why the heck would we want 210 rather than negative 150? Because 210 sits nicely on the unit circle, and negative 150 also sits on the unit circle, but you have to use your brain to figure out where it is on that unit circle. 210, once you have it drawn, you can just find it, right? So if I had 210, I could subtract 360 and get negative 150, which is also coterminal with 210. What else would be coterminal with either of those? What could I do? Because those aren't the only coterminals that exist with those two numbers. How could I keep going? So I took negative 150 and I added 360 and I got 210. How could I get the next positive coterminal angle? Yeah. Add 360 again. So I have 570. And then I could add 360 again, and I could add 360 again, and I could add 360 again. Or I could keep subtracting 360. So coterminal angles here, theta would equal, theta is just the angle, Looks like a little guy with a cowboy hat. My cowboy hat's really bad. No. You could have negative 150, negative 510, 210. What else was there in here? I can't even see them. 570. 52, 10, 570. Yeah. And there could be way more. We agree? How do you know which coterminal angle they want you to find on the diploma? Because it could be infinite number of ones. So how would they limit you? How do you think they could possibly limit you? Any idea? Pardon? X. But you're right. So if they asked if they gave you a restricted domain and they said they asked for the coterminal between 360 and 720, then you would give the coterminal that fell in between those degrees. It could limit you that way. So they could restrict the domain. Or what they could do is give you a multiple choice answer that only has one of these. There you go. Done. Now you'll say, what if it has two? They can't do that. They'll be both right. Like they can't do that. So they give you multiple choice with one of these answers, and you have to figure it out by adding 360 to the thing or subtracting 360 a whole bunch of times so you find one that matches. Or they give you a restricted domain, and they say between 360 and 720. Or they say between negative 360 and 0. Then your answer would be negative 150, right? So they can restrict your domain. So that's coterminals. I want you guys to sketch these. I want you to sketch them and then give me two coterminals. Yep. Go. Okay. So we have 40. Coterminal to it, you could go 40 plus 360 and you get 400. You could add another 360 and you'd get 760. Or you could have subtract 360 from it and you get negative 320. Or you could subtract another 360 and get negative 680. So here we would have 140, so it's 40 away from 180, so not exactly half. Coterminal with it, you could add 360. You get 500. You could add another 360, and you get 860. Or you could do 140 minus 360. What do you get? 2, 20, negative. Then we have negative 240. 0, I'm not sure why you guys are talking. Negative 90, negative 180, negative 270, negative 360. 240 is either 60 more than 180 or 30 less than 270, so it's here. If you go negative 240 and you add 360, you get 120. Or you can go negative 240 minus 360, and you get negative 600. Or you could keep going and subtract another 360, and you get negative 960. Right? It keeps coterminals could go on for life. And then negative 135. So negative 135 would fall here. And then you can go negative 135 plus 360. All right. So degrees are lovely, and we've been given degrees the whole time. I'm not sure why people are having conversations. Like you're doing notes. So we've had degrees our whole life, and degrees make sense because we've had degrees our whole life. I can wait. So if we do degrees and I give you like 240 degrees, you guys can basically, mostly of you can draw it. 180 you can draw, it's like one line. I give you negative pi and you're like, what in the heck is that? Negative pi is radian measured for negative 180. Okay? You are going to be given radians. You can revolt all you want and say, I don't like them and I'm never using them. You can, power to you. But if they give the question to you in radians, you have to have your answer in radians. Does that mean along the way you could possibly convert it to degrees so that you understand it better? Sure. But then you need to know how to convert. And then you'd have to convert back to radians because that's the answer they want. So how do we convert? So conversion. It's a measure. That's not a degree. That means the exact same thing. So why do we do radians? Well, if you had started learning radians when you were little, degrees would be foreign to you. But because you've learned degrees your whole life, radians are what's foreign to you. But why do we do radians? Because radians make sense in a word problem situation where degrees does not. So degrees to you, 360 is a full circle, right? And we could say that it rotates in 360 degrees. But what's going to happen is sometimes we're going to be rotating in 10 seconds. Well, how does that make sense? It only makes sense in radian measures. So that's how we learn about radians. So how do we convert? Well, degrees to radians, pi on top. Dr. Pot, you remember it. I know you will. So you probably giggle as you're along the way, but I do not care. You remember it. So what does that mean? It means degrees to radians, pi on top. So you are either, throughout this, going to multiply by pi over 180 to convert, or you're going to multiply by 180 over pi to convert. From radians to degrees or degrees to radians, it'll be 180 over pi or pi over 180. So if we remember that degrees to radians, pi's on top, then which one of those are we going to use? Pi over 180 or 180 over pi to convert from degrees to radians? Pi over 180 because it's pi on top, correct? So if I give you 180 degrees, and I want it in radian measure, which is just another form of measurement that means the exact same thing as degrees, but it's radians. We're going to multiply by pi over 180 because degrees to radians, pi on top. So what do we get? Well, this is over 1. When you multiply, a lot of people try to do cross multiplication. You only cross multiply across an equal sign. So that's why you cross multiply. You cross multiply when there's an equal sign between two fractions. Yes? When there's no equal sign, you just multiply across the top, across the bottom. So here, we're just going to get 180 pi over 180. And what happens? The pi's cancel. So, or sorry, the pi's cancel. The 180s cancel, and you're left with pi. So 180 degrees is the same as pi radians. So if I went to my little chart, instead of putting a 180 here, I could put a pi if I put radian measure around the outside, because they mean the exact same thing. So in degrees, I would have 180, this labeled as 180. In radians, I'd have this labeled as pi. It means the same thing from here to here. Is pi radians or 180 degrees. Same measure. So what if I give you 45 degrees? Degrees to radians, pi on top. So what am I going to multiply by? Pi over 180. So I'm going to get 45 pi over 180. Pi over 4. Why does it reduce it to pi over 4? Because you could divide by 45, the top and the bottom, and you get pi over 4. And when you press the button, you got 1 over 4. You have to bring the pi back. You didn't know the math enter button? Now you would give up your friend for it. You didn't know what you were missing before. Okay. Convert these. Convert from degrees to radians. Sorry, and I'm going to put inexact values. So we need to have a little heart-to-heart. Exact values. Massive heart-to-heart here. If I have the decimal 1.333333, and you round it to 1.33, you guys are telling me that that's an exact value. It's actually not. It's a complete opposite of an exact value. It's a rounded decimal that you made something else. It's not the exact value at all. You turned something that was actually 1.333 into 1.33 and kiboshed it and didn't make it an exact value. You just rounded something that was there. So actually, a decimal that doesn't stop or keeps repeating is not an exact value at all. Rounding it is the opposite of exact value. So what is an exact value? A fraction is an exact value. A reduced radical is an exact value. So an example, which has nothing to do with trig, but we have to have a heart-to-heart. If you have x equals 3 plus or minus root 2 over 7, and you turn that into non-repeating decimals, you are doing more work, first off, which you shouldn't be. And second off, you're not giving me exact values, giving me rounded decimals. If I wanted exact values, we'd be done. Woohoo, life is good. That is an exact value. The moment you punch those into your calculator and give me decimals, you are not giving me exact values. All right? Decimals that are rounded are the opposite of exact values. Quit doing that. Quit working harder than you need to. Okay? All right. So I want you to convert from degrees to radians in exact values. So if you went, for example, this one, 135 degrees, we're going to multiply it by pi over 180. The answer to this is 3 pi over 4 when you reduce it. 135 pi over 180. It's 3 pi over 4. Those of you who give me the answer can't even do the wrong answer quickly. 2.36. You are wrong. So if you went 3 times pi divided by 4 and gave me 2.36, which is the rounded decimal of this answer, that's not an exact value. No matter if you go to 7 decimal places, it's not an exact value. Some of you will say, but Lepp, I'll put 2.35619449. That's all the decimals on here. So it terminates. No, your calculator stopped there. It ran out of room. It quit. You know, because remember, you are smarter than your calculator, although you don't think it. You are smarter than your calculator. You know the moment you put pi in there, this baby don't stop. You're multiplying it by a non-repeating, non-terminating decimal. She don't stop. You'd be like, but it stopped. No, you're smarter than your calculator. It don't stop. Okay? It may look like it does, but you are smarter. And you know the moment you multiply by pi, that baby don't stop. Why would they ever ask us for not exact values? Numeric response. That's the only way. Then you would put the pi in. So most of you actually, to be blatantly honest, in this unit are really good. You guys give me this. And then I ask for it in a numeric response box to the nearest tenth. Do you know what you do? 3 divided by 4 and give me the answer. There's a pi. You have to include it if you're going to put it in. Okay? You do. You'll go 3 divided by 4 and give me that decimal. That's not 3 pi divided by 4. Is it in decimal form? No. So if I want it to the nearest tenth or hundredth, you'd have to go 3 times pi divided by 4, give me the answer. Often on the diploma, though, they don't ask for it to the nearest tenth or hundredth. They'll go a pi b, a b respectively. So then it would be 3, 4. Or what's a plus b? 7. Or what's a? 3. Or what's b? 4, right? They often will give it into you in this form and not even make you turn it to a decimal, because they can ask it in that form too, right? Which is just lovely, I know. Okay, so do these ones. So for this one, we're going to multiply by pi over 180, which gets you negative 210 pi over 180, which reduces to negative 7 pi over 6. 70 multiplied by pi over 180. So you're going to get 70 pi over 180, or 7 pi over 18. And then negative 540 times pi over 180 equals negative 540 pi over 180. They both share a 0, so you could take a 10 out of both of them. And then 54 and 18, you can take 9s out. You can take 6s out. Oh my goodness. Is it 4? Negative 4? Negative 3 pi? Okay, what if we go the other direction? Not super complex. It's radians to degrees. If degrees to radians, pi's on top. Radians to degrees, pi's on bottom. So most people memorize, yeah, you're welcome. Most people memorize Dr. Pot and then do the reverse. Some people go RD Pob for this one if you really want to. RD Pob's wonderful as well. So Say I give you 2 pi over 7. We are going to multiply by 180 over pi. What's great about this one? The pi's cancel. And I'm left with 360 divided by 7, which is what? It's the nearest tenth. I don't care. 51.4. Everyone's really good with it, and you have to put the degree symbol. Everyone's really good with this. But then I give you this. 2.67 radians. This should not be super complicated, but because the pi is inserted into that already, people get confused because the pi's don't cancel. Doesn't matter, just multiply by 180 over pi. And just go 2.67 times 180 divided by pi. Like you literally just type it in with the pi. Because we don't want a pi when it's a degree. You're not going to go like 2.67 times 180 divided by pi degrees. So it's 153 degrees. Your homework. It's as if I told you guys you like were in trouble or something. I don't know.